Welcome back. So, out of interest, how many people are in this room in the earlier two sessions? Okay, so I'm guessing that's about half of everyone. So for the half of everyone who is already in here, you either already know this before you came to the conference or you've heard a lot of the same material. So I'm going to apologize. I've been frantically trying to work out how to say this, say things in a different and fresh way. And I also have a lot of code demos, which I was rewriting this morning during Emily's talk. So fingers crossed everything will work. So now, my name is Alasdair Nottingham. I work for IBM. I've worked for IBM for too long, 17 years, since 2001. And I've worked on the application server. But I'm not going to talk about the application server massively today because it's mostly about MicroProfile. So before I go in and start talking about the MicroProfile APIs, I want to kind of reflect slightly on the last few years and how we have got to the point where we are really needing new APIs, because I think some of the context of really helps to understand why some things are the way they are and why they're important, rather than just assuming it is because everyone says it is. And at least from my perspective, this all started with Agile. When I first joined IBM and when I was at university, everyone talked about waterfall as being kind of a development model that was still considered to be in vogue. And of course, these days, if you came out of university and you said waterfall is the way to develop software, you would probably be laughed out of the room in most companies. And the reason why people wanted to adopt Agile was to get kind of faster delivery cycles, but also to kind of push decision making down and to break up kind of development teams so they could be developing and delivering more on their own. But it was really concerned originally with how do you develop and deliver code. And then DevOps came along, and what DevOps said was, we understand how to do code, but configuring machines is really hard. And, if a machine suddenly stops working properly, it's really hard to get something new set up the same way as it was before. Well, why don't we just script it all and write code? And then, infrastructure as code came into being. And that whole thing idea was let's integrate that into the development teams. The development team deliver both the code and some scripts which would allow the machines that the applications run on to be set up and provisioned and reproducibly. And the first time we were being told about DevOps and the need to do DevOps in IBM, we were still in a world of, you'd go and ask for a virtual machine, you'd set up a virtual machine, and the virtual machine would exist and live there for, a year, 2 years maybe. And then what cloud did is it came along and brought along the idea that, these things, these machines, you get them for a relatively short period of time, you set them up, you run them, you throw them away. So for example, within the team I work in, one of the advantages it gave us was instead of having to constantly worry about making sure the operating systems and all the software was patched, we would just throw it away and re-provision something from scratch. So you would get the base image to be updated with all the fixes, and then you'd re-provision all of the machines. And that gets integrated with your DevOps flow and your Agile development flow. And that's what leads to the essential desire to go with microservices, because when you have lots and lots of teams all trying to work independently, trying to coordinate and get all of the application code to run in a single JVM and a single application server requires a lot of coordination, which slows down the delivery cycle. So as fast as you can go with Agile and DevOps and the cloud provisioning, you also need to be able to get the teams to be able to work more independently of each other. And that's kind of where microservices come from. The problem with that is the general approach is use kind of REST APIs or messaging APIs to get the interaction between the services working, which brings you into the whole world of distributed programming, and you get a whole load of additional problems that you didn't have to worry about with the older ways of developing and delivering applications. And So when you look at what you want from your kind of cloud native and your cloud environments, you want APIs that support distributed computing. You want something that starts up and shuts down very quickly, especially if you're trying to do scale up. You want to scale up because your workload is increasing. You don't want to have to wait 25 minutes or 30 minutes to be able to cope with a sudden burst of new requests. You want it to be a small footprint because quite often you're getting charged based on the memory footprint or the CPU footprint or the disk footprint in these environments. You want something that's very small. And you want to have development, production parity. You want it to externalize configurations. You want it to be very easy for you, your developer, to deliver something, and then that gets deployed into the multiple different deployment environments you might have with different configurations. So your developer doesn't have access to production databases. Especially in the GDPR world, you don't want your developers to have access to production databases. And increasingly, people want things to be easily containerized because Docker is kind of fast becoming the go-to way of getting your applications deployed in clouds. So Java EE, or as it is now becoming Jakarta EE, has existed for quite a while. But over its history, what's happened is two things have happened over its history. One is it's got a lot of capabilities being put into it, and some of those things aren't in vogue anymore. If you're writing microservices, you're almost certainly not using IIOP as the communication layer between your microservices. It's much more likely that you're using something that is lightweight messaging like Kafka, or you're using REST. The other problem that this stack is, other than you've got an awful lot of technology most people aren't using, which led to Java EE and Jakarta EE having a reputation of being bloated, is the release cycles for Java EE have been slowing down at the same time as the industry has been trying to speed up. So it was, this was identified as a problem a few years ago, and some people from Red Hat and Tommy Tribe and IBM and a few other people were at a conference, and they said, we need to do something about this. And that is the genesis of the MicroProfile project. And, these problems that exist around it looking big and fat, almost everyone in the industry is trying to deal with this. How can we deliver the Java EE capabilities without everyone having to take everything? So with Liberty, which is the runtime that I work on in IBM, we took an approach that we would decompose the Java EE specifications into things called features, and you could configure and mix and match the features you want. So if you want to have JAX-RS and you want to do Open API, you can get those two things, but you don't have to take the EJB container, the web services stack, and so on. And in fact, we're not the only people who are thinking along these lines, because Thorntail, which is the new name for Wildflow Swarm, essentially has the same model. You can opt into the parts of the runtime you need. The advantage of this is it means that your runtimes get smaller, they start faster, and they use less memory for the application needs you have. So all of that thing about Java EE being kind of big and heavyweight is kind of no longer true unless you're still using an application server from like 10, 15 years ago. So Eclipse MicroProfile is the Eclipse project we started, I think it was a year and a half, maybe 2 years ago now. And it's actually got quite a lot of companies who are involved and interested in it being successful. Most recently, Lightbend and Microsoft joined the party, which is really interesting and useful. Some of that was driven, I think, partly by interest in and the movement of Java EE to Eclipse. But what we're trying to do at MicroProfile is to accelerate the delivery of new programming models that build on kind of Java EE. And originally, when Java EE was still in the JCP, we thought we'll develop these in MicroProfile and then we'll standardize. Not sure exactly what's going to go on with the relationship moving forward, but it'll work. We'll make it work because most of these groups are involved in Jakarta EE as well. So as I said, if you're doing microservices, I'm going to move into demos. You're probably using REST APIs. When we started talking about the base of MicroProfile, we said, let's just start with REST. We need to start somewhere. And we originally defined CDI, JSON-P, and JAX-RS as the core kind of REST components. And much more recently, we've added a template-based REST client. And there's, I think, another talk that maybe another talk on that? Nope. Okay. So I'm going to do a quick demo of all of these. And in my demo, I have probably the most over-engineered bit of Java code I've ever had the misfortune of writing. And I write Java code, which means almost all of the Java code I write is over-engineered in some way. I have a service called service C, which returns system properties. And I have a service A, which essentially just returns the results from service C. And the reason for this is service A can call service C and basically tell service C to simulate several bad conditions. So I can ask service C to do something differently based on the input parameters to demonstrate some of the microprofile capabilities. So I'm going to, let's go and find code. So, okay, I assume people can read this. So basically this is my service C code, and I have a method, and basically what it does is it takes property, you give it a mode and a property name, and it basically, what this bean here does, I'll show you in a second, but it basically looks at the mode, and based on the mode, it does some different behavior. So if you say you want it to be slow, it adds a sleep, so it'll take at least 2 seconds to respond. So it simulates a service that's having some kind of issue. Or it returns a failure, or it returns a failure sometimes. And inside of my bean code, it's just doing system.getProperty, which is kind of why I say it's the most engineered code I've ever written. And in service A, I have a REST API, which basically is calling a helper. And the helper, in this case, is just apparently not compiling. I've been having problems with VS Code. And it calls the client interface using getProp with none. If you look here, what I'm doing is I'm having objected the REST client, and if I look at the REST client, it's using the template-based approach. So you annotate it with JAX-RS annotations, and you say it's registering a REST client. And then on the method, I say, when someone calls this method, I want to do a get to this path. It produces application JSON, and I specify this will go through as a query parameter, and this is a path parameter. So when you call I've not had to implement the interface, I haven't to write any JAX-RS client code, I just had to annotate the interface. I can then get it injected, and I am really hoping that when I run through this, it works, and the compile error isn't something I need to worry about. Okay. Apparently, I'm not being lucky. This did work before I came in. Let's see. If I do package, let's see if my Maven compiles. Yep. Okay, so that's all compiled, so hopefully. Yep. Okay. So now, all I'm doing, you'll notice, if I zoom in, so you'll notice here, I'm not doing anything special. So I'm asking for service name, and it's telling me it's service C. But if you look in the URL path here, it says I'm calling service A rather than service C. So this is just to demo. What I'm doing is, I have a demo later where this will return a different value. But this is just showing I'm kind of just proxying it through. Okay, so if that's just the very basics of how the sample is working, MicroProfile also is trying to look at how you providing APIs to let you manage services when you have a large number of them. I say hundreds here, but for some applications, 10 might be a large number. So we've added APIs for health check, OpenAPI, and metrics. and I have 15 minutes left. And if I go back, I'm going to just show the health check, which is here. So I've written I've got my health endpoint, and I can hit this and refresh it. And what the code is doing what the code does is it's making, I don't know how to, okay, that's better. So what the code here is doing is I'm getting the URL to service C injected using config. I'm creating the JAX-RS client, not the same one I used before. I'm now using the code I would have written otherwise. And then when I go do a GET request, and I look for status of 200, and I return false. So if I were to go and shut down the service C, which I can do, this is, make sure I shut the right one down. Yep. So if I shut down service C and go back and now refresh, you'll see it switched to down. So I wouldn't recommend kind of writing health checks quite in this way, because you should write your code to be resilient to service C going down and be able to cope. But this is a simple way of demonstrating that your health check can write some code and do some logic to work out whether it's up. And what you might do inside of the health check is do things like make sure if you're calling your own database, make sure the database is up. You might be looking at, you might be starting up, so you're making sure any internal caches. And you indicate that you're down until your internal caches are built up, and that means that when you're running in a cloud environment, you can make sure that the front-end router isn't routing traffic to you. So if you're in a Kubernetes environment, it can check this health point, and until this returns up, it won't route traffic to it. So I'm just going to bring that up. Another thing that we did is we've got here is we can generate open API documents based on the JAX-RS annotations. You can also provide an open API documentation for your REST API, and you can annotate additional data into your JAX-RS. And the nice thing about that is you can then get a user interface. You can kind of use this this open API browsing application and start interacting with it with the API. So if I want to say I want to do a GET, it tells me that there's a mode query string and a prop query string, and I can try it out. And I'm not going to indicate what a mode is, but I'm going to say I want a property. So I'm going to say java.home. And then if I click execute, it'll load. It'll tell me the Java home of my Java is installed there, and apparently I'm using Java 9, which I didn't intend to do. So fingers crossed everything works when I'm using Java 9 rather than 1.8, which is... the other thing that we added, if I go... okay, now where was the... not here. Another thing we added is... metrics. So one of the things that Java EE didn't really have was a way for applications to contribute metrics. Most application servers defined some metrics. There were some specifications that defined endings for metrics, but there wasn't any way for an application to say these are the metrics that are important to my application, as opposed to these are the metrics that the application server thinks you might be interested in. So what we did in MicroProfile metrics is we defined some annotations and some APIs for building up your own application related things. So for example, on this method, which is in service C, I have an @timed annotation and an @counted. What @timed does is it says time how long the method executes for. And you can then get this information fed into something like Prometheus, and which is a monitoring tool. And your monitoring tool can then do things like tell you when your method invocation is starting to slow down, and that might be an indication that there's a problem and you need to take corrective action. And you can apply it to the methods which you think are important rather than it being, say, the servlet methods or the JAX-RS methods. So any CDI bean can have this. If you know there's a CDI bean that's expensive or is likely to hit these kind of problems, you can put the annotation around exactly the code that you're interested in. And I've also used @counted, which basically counts the number of times something is executed. So if I go to the Prometheus user interface, and I'm just going to refresh this, you'll see there's been a graph of where I've been testing it, and then because I refreshed it, there's been only one invocation, which hopefully you can read there. And if I go back and I refresh, let me refresh service C directly. It should, yeah, you can just about see it's upticked to 2. So there's been another invocation. So when I do an invocation, it gets presented here directly. Okay. So the next thing I want, oh, I've done that. So being able to monitor isn't necessarily enough. You also want to be able to, we also thought we needed to provide some additional APIs to the programming model to deal with these distributed systems. So I've shown you a little bit of config. I'm not going to show JWT because I don't have time, but I have got a couple of examples of using fault tolerance, and you've seen some of them already. So I may be going over some new ground, but if I go back, this is the bit that I'm a little bit nervous about because I redid it all this morning. So in the service, not this one, okay, this. So in service A REST, I've got this fetch service prop helper, and this fetch service prop helper, if I show it to you, it just is calling client get prop with none as the mode. So what I want to do is I want to simulate an error condition. So what I'm going to do is I'm going to tell the downstream service that I want it that's weird. Oh, that's right. None of the qualifiers are compiled now. Okay, great. That's fixed that one. So I have this this bean here, which basically is exactly the same as the vanilla one, except I've said sometimes. And what service C will do when I say sometimes is it will fail every other time. And then all I need to do in my REST service is tell it to inject the @sometimes version of the bean instead. So now if I go back to here and I go refresh, it says error 500, I can't resolve. And if I refresh again, it works. And if I were to look at Prometheus, if I refresh the graph, you'll actually notice up here it's got 4 because I'm actually simulating a failure as opposed to so it's got into the target bean. But, you know, nobody wants, you know, if you're the owner of service A, you don't want to be called out when service C starts spitting spurious errors at you. So what you can do in this case is you can use the retry. You can use the retry annotation. So if I add @retry to this method, what it'll do is it will ask a CDI interceptor to be configured. So if it fails, it will automatically do a retry. And it's configurable how many retries, what time units to put between, but I'm just adding an @retry annotation for the simple case here. And now if I refresh, it takes a little bit longer, but it's responding each time. And again, if I go to the Prometheus, you'll see it's gone up. And it's at 8 at the moment. If I go back and refresh again, and I come back and refresh here, it should have gone up to 10. And it has. So that's how you can see it's doing 2 requests, because Prometheus is telling us there have been 2 requests, despite the fact I only did a single refresh that time. So that's how to do, that's how you can use retry. Another thing you might want to do is you might have the service which is getting into trouble. It's slowing down. Maybe there's too much load on it, so each request is taking longer. So I'm going to inject a different version, which is the slow version. And if I look at the no timeout helper, which is what I get injected when I say slow, I'm putting a mode in of slow, and what slow tells Service C to is just to wait for 2 seconds. So if I go back and I go and request it now, it's going to take a little bit of time, and this is kind of dull to watch, but you'll notice it's taking a bit longer to respond. So that's not great for me because I've now missed my SLA, and I'm getting phone calls from my clients telling me, why are you slowing me down, rather than Service C having to be dragged out of bed at 2 a.m. in the morning. So in this case, what I'm going to do is I'm going to add out the timeout annotation, and I'm going to tell it I want it to time out after 500 milliseconds. So if I go back now and I refresh, it's going to do about 500 seconds, and then I'm going to get a nasty, horrible error. So now my client knows that there was a timeout condition, which is really great, but I'm still being called out of bed. So I've met my time SLA, but I haven't met my API agreement because I'm still returning failures. So I'm still going to get pulled out of bed early in the morning. So in this case, to deal with this, what I'm going to do is I'm going to define a fallback. And you can just add an annotation of fallback. And I'm going to, in this case, I'm going to say a fallback method of fallback. And then my fallback method is going to call fallback. And I'm going to return new prop name, and then I'll do system.getProperty. So what I've done here is the method parameters are exactly the same. The method return type is exactly the same. It's just the method name is different because they're in the same class. And when it fails this time, after 500 seconds, it's just going to call this one. And the way you'll be able to tell is it'll start returning service A rather than service C. So if I refresh, it says service A. So this is how you can tell that it has done the fallback logic. And if I went back and I changed the mode, I could get it to actually do the call again. So that's the demo of config. There are more things which I don't have time to demo. There's support for the circuit breaker pattern. This was, I think, demonstrated in the first talk this morning. It basically allows you to do kind of self-healing. So if you get a certain number of failures, it'll stop calling the downstream service. It will automatically call your fallback method if you've got one set up. And then if the target service comes back up again, it will kind of self-heal and start calling it once the target service is in a good state. There's also bulkheading. So if you have a downstream service that has some kind of constraint along how many requests it can handle, you can make sure you don't pass it so many requests it can't deal with. So if, for example, it can only deal with 10 concurrent requests, or you can say only make 10 concurrent requests at a time. Queue the other ones up until the next one is done. Now, one of the questions that quite often comes up is, can't you do it with a service mesh like Istio? And the answer is sort of. The reason I say sort of is because one of the nice things about Istio is it gives you the ability to add some fault tolerance behaviors at the network layer. And that means that you don't have to code it all in your application. The thing to be aware of when you do this is it's a little bit less flexible because it's only at the network layer. So if you want to do your kind of fault tolerance around a group of network interactions, like 2 REST calls or a REST call and a database call, then you can't, because it would be applied to each outbound call. The other issue is that Istio can't deal with HTTPS because if you want HTTPS to be end-to-end encrypted. So if you want to use Istio, you need to have HTTP from your service A to the Istio, and then the HTTPS would go from there onwards. But you don't have kind of end-to-end security. So there are kind of some limitations with Istio. There's a kind of place for both of them. So what's next? Java E8, that's kind of imminent, I think, in the next version of MicroProfile. I've just shown 1.3. There's a very active work group looking at how to bring reactive programming models to MicroProfile. I have to say, it kind of breaks my brain, the whole reactive thing, but at the same time, I know enough to know that it's actually something that is really important, and I'm trying to get my head around it. There's a discussion at the moment about data access, because there's no statement on how to access data. It's kind of default to either you do it yourself or use JPA, but JPA is not part of MicroProfile. There's a work group on how to improve the integration with Istio, because what you don't want to do is have an application annotation and an Istio captured for a retry, because if they're both retrying 5 times, you're going to be ending up retrying 25 times in total at the network layer, which is kind of crazy. And of course, we're always updating the existing specs to make them better based on feedback. And one last thing on deployment. There was a question from an earlier session about why you would use a kind of a hollow jar approach, and there was an allusion to Docker, so I decided to keep this in my deck. Spring especially makes a big thing about kind of uber jars or fat jars, depending on whether you want a slightly negative or slightly positive spin on them. And it makes it very easy for distributing your application and running it, because you just do java -jar, but your kind of jar file is quite big, which means every time you make a code change, you're ending up pushing a rather large binary around. So if you look at the Pet Clinic Spring Boot example, it's about 40 megabytes. The actual application is less than 400 kilobytes. So if you're distributing an Uber jar around for that application, every time you deploy, it's 40 megabytes being transferred around the network. That's not a problem if you're deploying like once a week, but if you're trying to do continuous delivery and every commit is resulting in a deploy into production, you're probably doing hundreds of deploys in a day, at which point the difference between 400K and 40 megabytes is significant. And that's where things like hollow jars come in. Because what you can do is you can have a specific layer for your essential kind of application platform, runtime server, whatever you want to call it, separate from the application layer. And because of the way Docker works, although you think of a Docker image as one thing, it's actually a series of layers with pointers to other layers. So if you're pushing something, it will only send the layers that need to be sent. So in the left-hand case, if all you've changed is the application code, it's only going to transfer the 400 kilobytes for the application, which makes deployments faster. So I'm out of time, so I'm just going to say, this is the summary. The thing that I haven't mentioned already in any way, shape, or form is, if you want to know more, if you go to this URL, on the Open Liberty website, we have a whole bunch of guides which go through every single one of the technologies in MicroProfile. There's even a couple of interactive ones. So if you don't want to get kind of code on your laptop, you can kind of learn and understand some of the patterns directly using in the web browser. So thank you, and I think I'm out of time for questions, so I'm sorry.